Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 994, rotting oranges. We're told that we're given an n by n grid where each cell can have one of three values: 0, which represents an empty cell, 1, which represents a fresh orange, or 2, which represents a rotten orange. And every minute, any fresh orange that is 4-directional adjacent to a rotten orange becomes rotten as well. So in this example, we have a single rotten orange, but every minute, so every cycle, we can see more oranges, specifically all 4 directional adjacent oranges also become rotten until the entire grid is fully rotten. And we need to return the number of minutes it takes until we have no fresh oranges left. And if this is impossible, we return -1. So how can we know if this is impossible? Well, we can know that if the time, how long it takes by using breadth first search. We can populate our queue initially with rotten oranges and then measure how long it takes until our queue is empty. But what about if there is an orange which is disconnected from the rest of the grid? What do we do then? Well, we can initially store the number of fresh oranges, and let's say that's 3. And if we come across 2 oranges, which we can decrement our fresh counter by 2, which will leave us with 1. And even if we do finish our queue and we finish our breadth first search, we'll still have 1 orange left, which we know is somewhere else in the grid. It's not connected to the other oranges, so we return -1. Okay, so let's hop in our code. Today we're going to be using TypeScript for the solution, and we want to start off with getting all the number of rows. So we're going to say grid.length, and the number of columns is going to be equal to the length of the first column in our grid. Okay. And we also want a queue. So this queue is going to be a 2-dimensional array of numbers. We'll say it to an empty list. And we want our time, which initially we're going to store as -1. And I'll get to that in a second. And we're going to have fresh, which is going to be equal to 0. And fresh is going to be the number of initial fresh oranges in our grid. So now let's iterate through all the rows and columns. So let's set row equal to 0, rows less than rows, row plus plus. So we're just iterating through the grid, going through every cell in the grid. Do the same for C. C is less than columns, C plus plus. Okay, and we want to say if our grid is a 1, so if grid RC is equal to 1, well, we can increment our fresh counter by 1. Or if our current cell contains a rotten orange, so it equals 2, we'll push to our queue.push our row and column coordinates. Okay, so that's populating our queue and initializing all our variables. Now it's time to actually perform breadth first search. So of course we need our directions. So let's get our directions as with any breadth first search problem. 1 and 0, -1, 0, 0 and 1, and 0 and -1. And we want to say while, actually no, let's actually get into our breadth first search function. So we're going to say function depth first search. Oh, so actually not depth first search, it's breadth first search, isn't it? So function breadth first search. Well, we don't even need to actually make this into a function. We can just keep it as it is. So we're going to say while queue.length. Let's increment our time by 1, and let's get our size. So our size is going to be the size of the length, because as we are iterating through our queue, we're going to be shifting, and we don't want to use queue.length. We want to keep it at initial size so we don't mutate that size. And we're going to say for every element in our queue, so I is less than size I plus plus, and let's get our row and column by doing queue.shift. Fantastic. And then what we need to do is get the row and column, every row and column of directions, or we can just say dr dc dr dc, if I can spell correctly today. And let's set our new row and our new column equal to r plus dr, and nc is going to be equal to c plus dc. And then we need to check if we're out of bounds. So if this new row and new column is out of bounds, or it's not a fresh orange, then we don't want to do anything. We just want to continue. So we're going to say if nr is less than 0, or nc is less than 0, or nr is greater than rows, or nc is greater than rows, or if grid nr nc does not equal 1, we want to just continue. We don't want to do anything here because it's either out of bounds or it's not a fresh orange, which we can make rotten. So we do a rotten orange, or it's just an empty cell. Okay, so if we do have a fresh orange, we can get our new row and new column and set it to 2. So now our fresh orange becomes a rotten orange. We can push to our queue our new row and new column, and we can also increment our time by 1. And we can, no, actually we don't need to do that because we've already done that at the top here. So we can just decrement our fresh counter. Okay, so that's our breadth first search done. And the next thing we can do is return fresh equals 0. And we're going to use a ternary operation here, and we're going to say math.max of time and 0. So why are we doing this? Why don't we just return time? Well, if the grid is empty, we're still going to return -1, which is not what we want. We want to return at least 0. So the minimum number we can return is 0. Otherwise, -1 if there are no, if we still have fresh oranges left, we just return -1 because it means we haven't made them all rotten. So let's submit our code. Let's check that this solution actually works. And we have a problem. Else if this should be. And our canonical property of undefined reading 0. Okay. If nr is less than 0, or nc is less than 0, and c is c plus dc, and r is r plus dr. Okay. nr is greater than, nc is greater than columns. That's what this should be. Or actually, it should be greater than or equal to columns. If nr is greater than or equal to rows, or nr is greater than or equal to columns, because we do have a 0 index-based language that we're dealing with. And now our code works. So in terms of time complexity, guys, we're looking at an O of m times n, same as space, O of n, big O of m times n, where m and n are the number of rows and columns in our grid. With that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.